Right. Hope you can hear me. Let's start the class. Today, if there are any questions, you can ask me directly via the chat, or you can unmute and ask the questions. Right. So, I'll be doing the paper discussion on ST8, the last class. Okay. Now, I think I have for the first question, I have explained this one, but it is roughly explained. So let me explain properly. The question is, this is ST8, right? ST8 discussion, this one. When an electromagnetic radiation of wavelength 300 nanometer strikes a metal surface of sodium, electrons are emitted with kinetic energy of 1.68 into 10 to the power 5 kilojoules per mole. Is it 5? Oh, yeah, 5 kilojoules per mole. What is the minimum energy needed to remove an electron from sodium? Now, the theory is like this. Now, if there is a metal surface like this, if a photon is coming into hit the metal surface, right? So we have to assume that this is a metal surface and some light is going to hit some series of light. That means photons, series of photons is going to hit by this metal surface. Then they are having wavelength of 300 nanometers. So lambda is 300 nanometers. Now, when this electromagnetic radiation means it is having photons. If this is going to hit by the surface, what happens is the electrons are absorbing the related energy from these photons. Now, electrons are having attractions. They are having attractions towards the nucleus, and they are having repulsions as well. So electrons are in the middle of a series of attractions and reflections. So if these attractions are overcome, that means attraction energy will be overcome by the energy of the photon, it will start to release from the surface of the metal. This will start from the surface of the metal, not from the bottom. It is starting from the surface because surface electrons are exposed initially, right? So based on the exposure as well, we have to consider that part. Now, the electrons which is in the surface will be hit by the photons. Photons are having some kind of energy. Energy will be absorbed by the electrons. If that energy is equal with the attraction energy. Attraction is also having some kind of energy. So if these two are equal, that is the minimum energy to release from the surface. Then if further energy is coming from a photon, that further energy will be converted into the kinetic energy of the electron. Then it will be released and it will be going away from the metal surface as well. If this is only enough to overcome the attraction forces, then in that case, they will not be going away from the metal surface. It will be within the metal surface because there will be no kinetic energy. So therefore, if these electrons are releasing like this, it has some kind of initial energy. This is what is energy needed to release the electron plus kinetic energy will be there. This energy should be equal to h nu or hf, right? Usually, there was a question in the last class whether we can use f for instead of this nu. In chemistry, this nu is used for frequency. It is given in all the past papers and all the resource books and the teachers' guides and everything. F is not used. Mu is used. Nu is used for the frequency, for the notation of frequency. So I encourage you to use nu for the frequency, right? Now, and also this nu then is the minimum energy requirement to release electron. And this psi, not nu, sorry, psi is responsible for the energy of the electron. That means it's kind of like, you can think of like a potential energy of the electron, and that is responsible for the lambda or de Broglie wavelength, which is released by the electrons after releasing from the metal surface. Because we know electrons, when they are having some kind of energy, they are moving into the higher energy levels. Here we are not talking about higher energy levels. These are releasing from the metal surface. When these are releasing from the metal surface, they will have some kind of energy. That energy is responsible for some kinetic energy and psi. That psi is responsible for the lambda, de Broglie wavelength, not the kinetic energy, right? So this is the kinetic energy. So this h nu is energy of one photon. Energy of one photon is responsible for energy of one electron. You can assume like that, right? Because otherwise this question cannot be done. Now, we have been asked about the psi first. What is the minimum energy needed to remove an electron from sodium, right? They are mentioning about the kinetic energy as well, but the kinetic energy is given for 1 mole, right? So kinetic energy of the 1 mole of electron is 1.68 into 10 to the power 5. So in that manner, we can calculate the energy of 1 electron, because 1 mole means Avogadro number. So we have to find that first, right? So we can say like this. So we can write like this: energy of kinetic energy, 1 electron. 1 mole is 1.68 into 10 to the power 5 joules. This is for 1 mole. And what is for 1 electron? This has to be divided by the Avogadro number, like this. Your answer will be in joules. And also we can calculate energy of 1 photon. Energy of 1 photon E is equal to h nu. Also we know C equals lambda nu. So also C equals lambda nu. C means the speed of light. So E is equal to h is 6.626 into 10 to the power minus 34 into C divided by lambda. C is 3 into 10 to the power 8 divided by lambda 300 nanometers. That is 300 into 10 to the power minus 9. All should be in SI units. Otherwise, your answer will be wrong. Right? Unit conversion should be there precisely. Then we can calculate, and also we can say E is equal to psi plus Ke. So therefore, psi will be equal to E minus Ke. So psi will be equal to E. We have calculated 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 300 into 10 to the power minus 9 minus this total one minus kinetic energy. Now we have calculated that one, that is 1.68 into 10 to the power 5 joules divided by Avogadro number. You can do the math and you can take this answer. Right? So I'm going to take the final answer. We have to take this one. I hope everybody is clear on this one. So this is for the first question. First question, first part. Right? Second part, what is the maximum wavelength that will cause a photoelectron to be emitted? Right? So the photoelectron means now this electron is called as a photoelectron because this electron is released from an electromagnetic wave, right? So they have been asked, they are asking what is the maximum wavelength, right? So the wavelength, as I explained, this lambda or de Broglie wavelength is caused by this psi minimum energy, not by the kinetic energy, right? Otherwise, everybody who is having kinetic energy should be releasing some kind of wavelength. That is not happening like that. It should be having some kind of uh, potential. That psi is responsible for the lambda, not Ke. Right? Ke is half m square. That is a separate scenario. Okay. So we can say that psi, let's say this value is E1. You have to calculate this one. I'm not going to do this one. You can do this one, right? Little bit of math is there. So we can say for the second part, E1 is equal to H nu 1. And we have been asked about wavelength. Yeah, we have been asked about wavelength. So this will be C divided by lambda 1. E1 knows, so lambda 1 should be equal to HC divided by E1. You have calculated E1. So your answer will be in meters. E1 is this value. Huh? This is E1. I think this is clear for you. So you can take this answer to here and do the calculations. Okay. If there are any questions, feel free to ask any questions. You can unmute yourself or you can ask from chat as well. Chat Right. So let's move into the second question. Second one. පොඩි වෙලාවක් දෙන්නද මේ ටික ලියාගන්න. විනාඩි 10ක් විතර වගේ දෙන්නක් ලියාගන්න ටක් ගාලා. Don't take the answers. You have the time to take the answers. Okay. Meanwhile, let's treat the second question. A crystalline salt Okay, a crystalline salt on being rendered, anhydrous, rendered means heated, right? Not a similar word, but it is doing something to release H2O molecules. Crystalline salt means a salt. You know, salt means in the salt means the result of a reaction between acid and base. Acid and bases are react together to produce a salt and water. Sometimes this salt can interact with water and create a single combined molecule. Like for an example, sodium sulfate, sodium sulfate dot 10H2O for an example. So it's their characteristics. We are learning about those things. So this combined salt is called as crystalline salt. Crystalline salt. You know, water can be heated, right? Water can be released from heating. Sodium sulfate will not be impacted while heating. We are learning about those things in next block. So while heating, if you do the heat, this will be converted to sodium sulfate. Water will be released. So this is called as anhydrous salt. Salt without water. Yes.
සර් දැන් මේ සෝල්ට් එකේ නම එනකොට මේ දැන් සාමාන්‍යයෙන් අපි එච්චර වැඩි දන්නේ සෝල්ට් එකක් වුණොත් දැන් ඒකේ එලිමන්ට්ස් ලියනකොට ඒකේ ඕඩර් එක කොහොමද ලියන්නේ දැන් අපි NaCl කියන එක දන්න හින්දා අපි Na ඉස්සරහට දාලා Cl පස්සේ දානවානේ අපි ඉස්සලාම Cl දාන්න නැතුව පස්සේ Na දාන්න යන්නේ දැන් මේකට එන ආන්සර් එක කොහොමද ඊළඟට arrange
order එක ගන්න හැටි දාන්නේ.
ඔව් සර්.
හරි. order එක ගන්න එක හරි simple. සාමාන්‍ය salt එකක salt is consist of, for an example, I'm saying cation and anion. Usually cation comes first. Not usually, always cation comes first. Like if it is consist of Na plus and let's say carbonate ions, this is the cation. This is the anion. So cation comes first, anion comes next. Then when they combine each other, their valences will be shared, right? So you know this one minus 2O, the 2 will come here. Here it is 1 will come here. So this will be sodium carbonate. For an example, let's say what we can take magnesium chloride, right? Magnesium is consist of magnesium 2 plus and Cl minus ions, right? So this is the cation. Cation also always should come first. This is the anion, then anions comes next. So these two will be shared like this. It will be converting into magnesium chloride.
සර් එහෙම නෙමෙයි අර පහක් හයක් තියෙන එලිමන්ට්ස් පහක් හයක් විතර තියෙද්දි
මම කියන MgCl2. now ඔයා කියන්නේ දැන් මේ sodium sulfate වගේ එකක්ද නැත්නම් මට example එකක් දෙන්න මට කියන්න. ඒකේ හරි මෙහෙම කියන්න. සරලවම ගත්තොත් very simply you have to arrange them in increasing order of electronegativity. If there are many elements, like if there are many elements there, you have to arrange them in increasing order of electronegativity. But you have to be careful whether there is a group, like here the sulfate is a group, right? SO42 minus, and this is a group. So this group will be placed after a cation because this is an anion. Within the anion, it should be placed increasing order of electronegativity. Samanyan venne cation comes first, then anion comes. Within the cation or within the anion, they should be arranged in electronegativity increasing order. Now let's say if it is a covalent compound, for an example, CCl4. CCl4 is a covalent compound, but we never say this says Cl4C. What will happen in covalent compound is always central atom comes first. Central atom comes first. Now let's say for an example, uh, sulfur is connected to fluorine, chlorine, oxygen, and chlorine like this. And then මේක ලියන හැටි ප්‍රශ්නයක් තියෙනවා. මේක ලියන්න මෙහෙමයි. SClOF. So S is the central atom. After that, electronegativity increasing order. Right. හැබැයි අපි හිතුව මේ වගේ එකක් තියෙනවා කියලා. S double bond O, double bond O, Cl and Cl. Right. This is written as SO2Cl2. There is a reason for this one. You don't know about the reason for this one. This is not written like this. SCl2O2. මේක මෙහෙම ලියන්නේ නැහැ. Because oxygen is not written at the end of the molecule name with another one. Like for an example, H2O, there is no other way. But if there is a way to include oxygen before the final atom in the formula, you have to do like that. You have to write it like that way. I'm doing these theories at the end of the unit 3. There is something called IUPAC nomenclature. That IUPAC nomenclature lesson එකේදී මම මේ ඔක්කොම ටික කරනවා. ඒතකොට ඔය ඔක්කොම ටික clear වෙයි. පැහැදිලි වෙයි. දැනට roughly හිතා ගන්න. In covalent bonds, first you write down the central atom, then increasing order of electronegativities. For ionic bonds, you are first writing down the cation, then anion. Within the cation, if it is a group, it has to be arranged in electronegativity increasing order. If it is an anion is also a group, it has to be arranged in the increasing order of the anions. So likewise, that is how you arrange the elements. Okay, කරද්දි ඔක හුරු වෙනවා. කටපාඩම් කරන්න දැන් මතක තියාගන්න යන්න එපා. ඔක එක්ස්පීරියන්ස් එකෙන් ගොඩ යනවා වැඩි. දැනට ගොඩාක් පොඩි වෙන්න එපා ඒ කතන්දරේට. හොඳයි. Right. Now let's come back to the question. A crystalline salt on being rendered anhydrous loses. Now there is a salt, right? There is a salt. It is anhydrous salt. A crystalline salt. When crystalline salt converts into anhydrous salt, it loses 45.6 of its weight. So they are giving us a hint. If you take 100 grams of the crystalline salt, anhydrous salt, and water will be released now. Water is 45.6 and this is 54.4%. Sorry, grams, because if we consider 100 grams. So this idea is given. A kind of a ratio is given in between anhydrous salt and water, right? The composition of the anhydrous salt, they are talking about this anhydrous salt. It is aluminium, potassium, sulfur, oxygen, right? Potassium, aluminium, sulfur, and oxygen. Now, here, the ratios are given for aluminium, potassium, sulfur, and oxygen, right? Now, we can say mass ratio. This is 10.5, potassium is 15.1, sulfur is 24.8, oxygen is 49.6. Then you can calculate mole ratio. This is 10.5 divided by 27. This is 15.1 divided by 39. 24 divided by 24.8 divided by 32. 49.6 divided by 16. So I have the answer for this one. ඔයාලට මේ ගණන් දාන්නේ මේ ගොඩක් පොත් බලලා බලලා ඒ වගේ වගේ තමයි ගොඩක් වෙලාට දාන්නේ. ඉන්දියන් පොත් නම් බලන්න. පොත් ගොඩක් තියෙනවා ඒ වගේ ගණන් අපි ඔක්කොම ටික හදලා ඉවර කරමු. So here if you take this one, potassium will be having 0.38, aluminum is having also 0.38. I don't know, in this book they are saying like this, 0.775, this one, this is 3.1. So you are dividing this one from the 0.38. Make a very I'm just referring the book. I just want to show you something on this one. So this is 1, this is 1. They are saying this is 2 and this is 8. I think this should be correct. Yes. Then after that, I can write down this one. This potassium should come first because that is the least electronegative one. This is potassium, then comes aluminium. Then sulfur and oxygen is a group here. It is coming from the P block actually. You can learn about that one. So we have to write it like it. That is SN oxygen here because that is sulfur related oxides. Sulfur related oxides has created an anion that is combined with potassium aluminium cation group. Potassium and aluminium created cation group. Sulfur and oxygen is created an anion group. So those two has been combined together in the actual way, right? So this is S2O8. This should be the anhydrous salt one. Anhydrous salt empirical formula, right? Empirical formula. Now we can calculate the molecular mass of this empirical formula, right? So because we know we have been asked about calculate the formula of the anhydrous salt. Okay, now this is the formula of the anhydrous salt. That is done, right? So yeah, this should be the empirical formula. This is the empirical formula of this one. That is KAlS2O8. This is the anhydrous salt, but we need crystalline salt as well. Crystalline salt can be captured from this stat. If you take 100 grams, out of 100 grams, 54.4 is anhydrous salt and H2O is 45.6. Now I can calculate how much of anhydrous salt mass will be there, right? So molecular mass of, I'm calculating molecular mass of empirical formula. Here there is no way to calculate the molecular formula actually because molecular mass is not provided, but we can deal with empirical formulas. So we can take like this is 39 into 1 plus 27 into 1 plus 32 into 2 plus 8 into 16. උත්තර තියෙන වන්දානම් උත්තරේ හදලා ගන්න this should be 258. Now we know the ratio between anhydrous salt and the crystalline salt, that is and also water as well. So anhydrous salt to water ratio is 54.4 to 45.6. So if you consider if 100 grams of crystalline salt is considered, right? If that is considered, anhydrous salt divided by this is mass, water mass is equal to 54.4 grams divided by 45.6 grams. The same should be equal to anhydrous salt, that is 58 grams divided by water mass. Because in here also that ratio should be adhered, same salt, right? So therefore water mass should be equal to 45.6 divided by 54.4 into 258 grams. So this is the water mass. This is water mass, right? I'm considering a ratio because the percentage is given. Percentage can be taken as a ratio for this one. So you can take an answer for this one. I will give you the answer. This answer should be 216.2 grams. So this is the water mass. Then you can calculate water moles of this empirical formula, related to this empirical formula, right? So therefore, water moles will be equal to 216.2 divided by water is 18, right? 18 grams per mole. So they have calculated this one as to be 12. So that means within this empirical formula, the formula that we have calculated, there should be 12 H2O molecules, right? So molecular formula of the, empirical formula of the crystalline salt should be, that means this one. So crystalline salt should be equal to, empirical formula is Kal2S2O8 dot 12H2O. So this is the molecular form, empirical formula of crystalline salt. I have taken a simple ratio for the calculation, right, between empirical formula and water, because it is given at the beginning of the question. Okay. I will give you 1 or 2 minutes. Okay. Then we can move to the next question. We will not be given like the same type of questions always. We have to create something new out of the questions. That is ways usually. So there was a question. Okay, good. So the same thing, right? The answers. Yeah, there is no deviation for this. Right. So let's move on. I hope that you have taken the idea, right? Okay, there was a question. Molecular formula, same as the molecular formula of ionic compounds because of the lattice structure. That's a good question. The question is the empirical formula same as the molecular formula for ionic compounds because of the lattice structure? Correct. You can take that one like that way. I didn't mention that one because of a reason. There are some complex structures. I will repeat the question again. Empirical formula, same as the molecular formula for ionic compounds because of the lattice structure. That is correct. Because the lattice structure is a repetitive structure, right? So NaCl, I have drawn that one. One sodium is 6 chlorine. So likewise, always there is NaCl, 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 NaCl. So NaCl is same as the molecular formula and as well as the empirical formula. But when it comes to very giant structures, we are learning about those things. It is always not the same, but most of the time you can take this one as the correct answer or the correct statement. Empirical formula of the ionic compounds is always, not almost, how can I say, 99% is equal to the molecular formula. That is correct. But when it comes to the giant structures, it is not. දැනට එහෙම හිතන්න පුළුවන් ප්‍රශ්නයක් නැහැ. Here also the same scenario actually. This is also ionic compound, which we have done in this question. This one is also an ionic compound. So that's why empirical formula is equal to the molecular formula. It is not given, but you can proceed with the empirical formula. ඇත්තටම මේ කතන්දරේම තමයි තියෙන්නේ. The same thing, that because it is creating giant structure, lattice structure, the lattice structure is having the same formula as the empirical and the molecular formulas. Yeah, that's a good one. Okay, let's move into the next question, number 3, third question. Two oxides of a metal contain 27.6 and 30% of oxygen respectively. If the formula of the first compound is M3O4, find the formula of the second compound. That is quite easy. This is just the mass percentages are given. So let's say this is M3O4. If this is M3O4, the oxygen percentage is 27.6%. Yeah. And the next one is we don't know X. If the formula of the second compound. So this one we can take it as 2OX. Why I have taken this as 2? Because oxygen is always coming with O2 minus ions, right? M3O4, it is coming with like M3O4 means like it is a combination of two compounds. That's why it is. That's how it is created. Uh, but for the moment, I will take the formula of the second compound as N3OX. I need to find X then, right? If X is a kind of a decimal place, you have to rearrange the ratio. Or else then you can take it as MOX as well. That's fine. That's totally fine. Then you will have X as a ratio. Then you have to balance. You have to eliminate that ratio as whole numbers. Right? I'm just assuming that this is as N2OX. I'm just assuming. You can assume like MOX because that is also fine. In this case, here the oxygen ratio, oxygen percentage is given as 30%. So I will take molecular mass of M to be Y. Y is equal to atomic mass. Atomic mass of M. So considering M3O4 මේක හදන්න ගොඩ ක්‍රම තියෙනවා. ඔයාලට කැමති ක්‍රමයකට හදන්න පුළුවන් ඈ. රේෂියෝ එකක් දාගෙන හදන්න පුළුවන්. That's totally fine. So this one can be calculated. Oxygen mass percentage. So oxygen mass percentage should be 4 into 16 divided by 3y plus 4 into 16 into 100 should be equal to 27.6. This is the first equation. Then considering M2OX, you can take 16 into X divided by 2y plus 16x into 100. This is equal to 30%. So these are two sequential equations. You can solve it for X and Y. If you want, you can find Y. Or if you want, you can only satisfied with X. Actually, from the first one, from the first one, you can calculate Y. You can find Y and substitute value here, Y, and find X. Then make a X let's say M2 or 2.5 or something. We'll make a band. So what we do is we multiply both sides by 2, right? So we can place it like M4 O5. I'm just giving you some examples. Abhi to make our X as like 1.33. Then I will multiply this by 3. So this will be M6 O4, right? So likewise, you have to eliminate these decimal places by multiplying, same as we do for the empirical formulas, right? Multiply by a whole number until the decimal places are becoming a whole number, right? Here, I don't have the answer actually. You can take the answer at home. This is how you do this question. These type of questions are very common. Believe me, this is an MCQ question. Right? There are some several other methods as well, but I think this method is the most easiest one. the triggering point here is the formulating of this unknown oxide. You can take this one as MOX as well. That is totally fine. Then you have to find this X. If it is a decimal place, you have to multiply it by a whole number until a whole number becomes the X and other things, other numbers, right? Right. Let's move to the number 4. How many total spectral lines could be in Lyman and Balmer series when electron equals 5 from low energy levels? These are very popular ones. So electrons are n equals 5 or low energy levels, right? So it can be high energy levels. So low energy levels, then n equals 5. 5 is also there. So let's say this is n equals 3. This is n equals 2. This is n equals 1. So for the Lyman series, there will be one spectral line that is coming from 5 to 1, 4 to 1, 1, 2 to 1. So the spectral lines for Lyman series, and they have been asked about the Balmer series as well. So for the Balmer series, from 5 to 2, 4 to 2, and 3 to 2 can be there. Remember, we are talking about Lyman series and Balmer series. This can be seen in emission spectrums, not absorption spectrums. This can be seen in emission spectrum. So total spectral lines are 7. So electrons can be n equals 4, or like it can be in n equals 1 as well. It doesn't matter. By n equals 1, it is not creating a Lyman series or Balmer series. It can be avoided. Others can be has to be taken for the spectral line decision. වගේ ප්‍රශ්නයක් ආපුවාම හිතලා sorry ඇඳලා ගත්තට ප්‍රශ්නයක් නැහැ. Okay. There are 7 spectral lines for this one. Okay, number 5. So they are all of them are in ionization energies. So I will revise you the ionization energy things. Ionization energy variation across a period. So the first group, second group, third group, fourth group, fifth group, sixth group, again a drop, 17th group and 18th group. So this is the first group, second group, 13th group, 14th, 15th, 16th, 17th, 18th. This zigzag pattern should be there in your photographic memory. Otherwise, it's quite hard to understand the things, right? So first one is asking about the first ionization, increasing order of the first ionization energies. So, and also we know on descending a group on top to bottom, ionization energies are decreasing. That is the idea, right? So we have been asked about nitrogen, neon, sodium is in the third period. So this is the second period. This is the third period. Then we have potassium, fourth period, one is also given. Then phosphorus is given. Phosphorus is in the third period, 15th group. Then we have argon as well. Argon is in the third group. Sorry, third period, 18th group. So this is 18th, this is 15th, and this is first group. The groups are also given like this. So you have been asked about the increasing order. So definitely the lowest ionization energy is with potassium, the lowest one, because that is in the fourth period. Then you have to consider the third period elements, that is sodium, phosphorus, and argon. Out of these things, the least ionization energy is with sodium. Then comes potassium. Then comes argon. Then you have to go to the second period. In the second period, uh, nitrogen is the lowest in the second period, and neon is the next one because of this graph that I have drawn, right? So this should be the increasing order of ionization energies. Potassium should be having the least ionization energy because that is in the fourth period. Then third period elements has to be considered. A set taking, then least should be having the first group, then 15th group, that is potassium, then 18th group ones. Then you have to jump for the second period ones. Second period ones, nitrogen should be the least. Then after that, neon should be the highest. So this should be the order. So when you are given with something like this, you arrange them in a periodic table sketch. So it would be easy to understand them, right?
So nitrogen argon neon nitrogen වැඩිද first ionization?
Yes, nitrogen already because that is in the second period. It's a good question. So let's go move into the second one. Increasing order of second ionization energy of beryllium, boron, and oxygen. Now the second ionization energies, when it comes second ionization energies, there should be one drop from right to left, a shift from one position of the groups, right? So the black one is for the first ionization energies. Second ionization energies will be here. 18th one should be here. 17th one will be here. 16th, 15th. Then here it should be 14th. I'm talking of these red lines are the second ionization energies. So this one is the second one. The first ionization energy should be going into the 18th group of the next period. So it should be somewhere around here. So this is the first group of the second ionization energy. Now we have been asked about beryllium. So for here, you need to know about the groups of these elements, right? Beryllium, boron, and oxygen. Oxygen is in 16th group. Boron is in 13th group. Beryllium is in second group, not 12th, second group. We are asking about the second ionization energies. So if it is second ionization energies, beryllium should be here. Boron should be here. Oxygen should be here because that is 16th group. We are talking about the second ionization energy increasing order. So the increasing order should be the same order: beryllium, boron, and oxygen. We are talking about the second ionization energies. ඊළඟ ප්‍රශ්න ලේසි. Increasing order of the first ionization energies of the elements from lithium to fluorine. So you are asked about the ionization energy trend from lithium to fluorine simply in the second period. So the least should be with the lithium. I'm talking about this third one. Then comes beryllium. sorry, boron, then comes boron, 13th one. First ionization energy, right? So I'm talking about the first ionization energies. So this should be lithium, this should be beryllium, this should be boron, carbon, nitrogen, oxygen, fluorine. So the trend should be lithium, then boron, because 13th group is less than second group. Then comes beryllium, then comes carbon, then comes oxygen, because it is less than 15th group, then comes nitrogen, then comes fluorine. So this should be the answer for the third one. Then they're asking about, again, there is a mix of second and third and fourth. I will leave this one for you. You can do this one at home. Right, 14th group එක වලට ගෙදරදී හදා ගන්න පුළුවන් ඒක ලොකු ප්‍රශ්නයක් නෑ. Now you know how to do this one. Right. Okay. So tomorrow we will have the class. I'm doing some chemical calculation questions. There will be 1.5 hour class. So new chemical calculations questions will be done. Theoretical බලාගෙන ඉන්න. අපි ගණන් හදමු රෑ from starting from 10 pm. මේකේ paper එකේ ගණන් ටික දැන් මම හදලා තියෙනවා. බලාගන්න බැරි වෙන කෙනෙක් ඉන්නවනම් මම link එක දාන්න recording එකේ ඒක බලලා මේ ටික හදාගන්න. උත්තර ටික ගන්න එක නෙවෙයි වැදගත් වෙන්නේ. මම හැමදාම කියනවා වගේ උත්තරේ ගත්තේ කොහොමද කියන එකයි වැදගත්. මේක අරගෙන හරියට තමන්ගේ නෝට් එක හදාගෙන ඒකට ඇටච් කරගන්න. තියරි නෝට් ලිව්වට කමක් නැහැ. උත්තරත් එක්ක කිසි ප්‍රශ්නයක් නැහැ. මේක නම් ගොඩාක් තියරි අපිට සෙට් උන්නේ. හැබැයි අර පළවෙනි ගානේ තියරි එකක් තියෙනවා. ඒක ඔයාලා තියරි නෝට් එකට ගෙනිච්චත් ප්‍රශ්නයක් නැහැ. ඔතන ක්ලික් කරලා වෙනම කොලවල ලියලා අවශ්‍ය දේවල් ටික එක්ස්ට්‍රා ටික ඔකට ක්ලික් කරලා ෆයිල් කරන්න. පිළිවෙලට වැඩ යන්න ඕන. මේක නිකන් ලියලා පේපර් එක වෙන කොහෙවත් කඩු වැඩ කරලා දින වෙන කොහෙවත් මේක කොහොමද උත්තර ගත්තේ ඒ විදිහට තියාගන්න එපා. පිළිවෙලක් ඇතුව වැඩ කරන්න. උත්තර ටික ගත්තේ කොහොමද කියන එක පේපර් එක බලපුවාම තමන් මාස 5කින් 6කින් අතට ගත්තාම තමන්ටම තේරෙන විදිහට තියෙන්න ඕන මේක. වෙනම ෆයිල් එකක් මේන්ටේන් කරන්න පේපර්ස් වලට. ඒකේ එතකොට ටටක් ගාලා බලාගෙන යන්න පුළුවන්. කොහොමද කරලා තියෙන්නේ? කොහොමද උත්තර අරගෙන තියෙන්නේ? දැන් තාම මාර්කින් එකක් දෙන්නේ නැහැ. ඒ කියන්නේ ලකුණු කොහොමද දෙන්නේ කියන එක දෙන්නේ නැහැ. තාම අපි ඉගෙන ගන්නවා මේ උත්තර ලියන්න ඉගෙන ගන්න. පස්සේ අපි මාර්කින් එකක් තව ග්‍රැජුවලි හදාගෙන යනවා. අගෝස්තු මාසේ අපි ෆුල් ලකුණු දෙන පේපර් එකකුත් කරනවා. මම දවස් කියන්න. ඒකට කෙමිකල් කැල්කියුලේෂන්, කෙමිකල් බොන්ඩ්ස් and ෆස්ට් ලෙසන් එක සෙට් එකම සෙට් වෙලා හොඳ පේපර් එකක් අපි ලියනවා. පළවෙනි පේපර් එක විදියට අපි ඇඩ් කරලා අපි එක්සෑම් හෝල් එකක ලියනවා වගේ ලියමු. මේ එතකොට පේපර්ස් ඒ විදිහට පිළිවෙලකට වැඩේ යන්න ඕන. ටියුට් එකේ වගේම ටියුට් එකේවත් දැන් හදන්න පුළුවන්. මම කියනකම් ඉන්න එපා. ටියුට් එකේ තියෙනවා අරගෙන හදන්න. දැන් මොනවද? empirical formula, molecular formula ඕන තරම් ගණන් තියෙනවා. හදන්න. concentration දැම්මලා අපි ලබන සතිය ඉවර කරනවා. ඒකේ තියෙන දේවල් ඕන තරම් ගණන් තියෙනවා. හදන්න. තව මම සිකුරාදරයට හදනවා chemical calculation. ඒවත් එක තැනකට ගන්න. තමයි ටික ටියුට් එකටම ඇටච් කරලා ප්‍රශ්නයක් නැහැ. ඒක ඔයාලගේ එකක් හදාගන්න. මම කැමති ටියුට් එක දෙන ගණන් එක්ක සිකුරාදරයට අපි හදන ගණන් ටික ඇටච් වෙනවා. මේක ෆයිල් එකක් හදන්න. ඒ වගේ පිළිවෙලකට වැඩේ කරගෙන යන්න. හරි. හරි පුතාලා එහෙනම් අපි මෙතන ක්ලාස් එක නතර කරමු. හැමෝටම තෙරුවන් සරණයි. good night.